In this video, we're going to be looking at equations for sequences. A reminder, an arithmetic sequence is a sequence where all the terms have a common difference. So if I look at this one, it looks like my difference here is 4. Since I'm adding 4, I know that this sequence is arithmetic because I'm adding or subtracting the same number each time. In order to find the equation of a sequence, the explicit equation is similar to that of a linear function, similar to y equals mx plus b, but in this case I have t of n equals mn plus b, where n is the term number. So looking at this is the first term, the second term, the third term, etc. So in order to write this equation, what I need to do is I need to figure out what my rate of change is. Well, I know my common difference is 4, so that is going to go in where my slope would go in my equation. So I have t of n equals 4n plus b. Now this b is similar to that of a y-intercept in that I'm interested in what happens when x is 0 or when my term number is 0. So to get this equation, I have to work backwards 1 to my 0 term. Okay, if I'm adding forward, moving to the right, as I move to the left, I would need to subtract 4, and that would be 1. So my explicit equation would be t of n equals 4n plus 1. To check that that fits, I would put in a 1 for n, and I should get whatever my first term is. So my first term is 5, and that matches what I have up here. I could put in a 2 to find my second term, which would be 9, which also matches what I have in my original sequence. So I can do that to check that my equation is correct. The other type of equation that you will often see referenced is the recursive equation or the recursive formula. In order to recursively define this sequence, I need to go ahead and just list what my first term is. My first term is 5. And then I need to tell you how to get to my next term, which is a sub n plus 1, when I'm comparing it to my first term, or my current term, I should say. So I get to my next term, the n plus 1, by taking my current term and adding 4. So this would tell me I would get to my second term by taking my first term plus 4, and that works. I would take my third term would be my second term plus 4, so it's just showing the relationship between them. In order to list my recursive formula, I need to have both of these pieces of information. Now let's take a look at a geometric example. A geometric sequence is a sequence where the numbers have a common ratio, which means we're multiplying by the same number. And the formula for a geometric sequence is given by this one here, t of n equals a times b to the n power, where n is the multiplier, and b is the multiplier, and a is the 0 term. So if I look at this sequence here, I am multiplying by 2 each time for each term. So my equation is going to be t of n equals my 0 term times 2 to the n. Then to find a, I just need to work backwards here. If as I move to the right, I multiply by 2, when I move to the left, I'm going to take 7 and divide by 2. So I'm just going to leave that as 7 halves. Okay, if I were asked to give the recursive equation, what I would do then is I would list my first term, and I would list how I get to my next term by using this first term. I would just multiply by 2. So I would write a sub n plus 1 equals a sub n times 2, or you may see this written as 2 times a sub n. Either one would be acceptable.